Alright guys, so the last subsection of this section 1.3 concludes with sampling techniques. Okay, so when we're ready to actually take our sample for an experiment or a study, what's going to ensure that we obtain a sample that's that's most representative of the population? So that's what we're going to look at. So, ideally, it would be great if we could just sample every member of the population, whatever that population is that we're considering. But like I said, have said previously, that's in most cases difficult, if not impossible. Okay, there are a few cases, and when we are able to actually do that, we refer to that as a census. Okay. It counts or measures the entire population. We actually have a census, right, every 10 years. And that's what it attempts to do. But even, we call it a census, but it's not actually a true census because it doesn't capture everyone. But yeah, like I said, most of the time it's expensive, difficult, and typically just basically impossible. Because if it were possible, then we wouldn't really need statistics, or we wouldn't need sampling methodology. Okay. All right, but in all other cases, we're going to use sampling. So, as we've talked about, a sample is just a subset of the population. And then we can use that sample to make predictions or generalizations about the population. Okay, but we've got to be pretty careful, guys, so that to ensure that the sample is representative of the population. These are some different strategies to do that. So the first one is a random sample. So a random sample is just one in which every member of the population has an equal chance of being selected. So basically, one individual is not more likely to be selected than any other individual. Okay. And then we have a simple random sample. This is a sample, this is a bit difficult to understand, but it's a sample in which every possible sample of the same size has the same chance of being selected. So what I mean by this is, let's say we're taking, we're sampling members of a population, and we want the sample to have 20 members. Okay. Remember, when we say population, we're not necessarily talking about people. It could be whatever we're interested in. It could be all the trees in a certain forest. Okay. But let's say we're going to start taking samples of 20. So this simple random sampling that just means that any group of 20 is just as likely to be chosen as any other group of 20. So for example, if we were to take every single possible sample of 20 members, and then from that group we were just going to select one, okay, we would say that each of those groups of 20 are just as likely to be selected as any other group. Okay, so it's sort of like the random sample, except with actual groups. Okay, samples themselves instead of members. All right, and we can use technology to help us create a simple random sample, and I'm going to show you guys this. We can use our TI-84 calculators. There's other software. You can use Excel. There's probably all kinds of free software online that'll generate random numbers. So anyway, it tells us here, it says you're going to press the math button, so I'm going to demonstrate this for you. Oops. Clear this screen. Let's clear this screen too. So you're going to hit this math key, and then you're going to scroll over to the probability column. So that's this fourth column right here. So you're just going to go to the right, and then you're going to scroll down until it says, well, I think it's this random integer. Yeah, random integer. And then what you're going to input is a starting number and an ending number, and then how many numbers to generate. Okay, so I'm going to select this, And let's say we're starting with 1. So typically when you're doing this, you would actually label all the members of a population. And then this will randomly select some of those members, okay? So let's say the population consists of 100. So I'll put a comma in here, and I'll put 100. So we're going from 1 to 100. Now I'll put a third comma, and this is where I put in my sample size. So what this will generate is just a list of numbers between and including 1 to 100. And let's say we want a sample size of 10. So put a 10 in here. I'm going to close those parentheses. When I hit enter, it'll give me a list of 10 random numbers within this range or within this interval that are random, okay? And so the way you would use this in real life is you would actually assign a number to all the members of the population and then use a tool like this. And whatever numbers are generated, those are the members that you select to be part of the sample. So when I hit enter, then I get this list. Okay, so 95, the 91st member, the 15th member, the 52nd member, etc. And you can scroll over the 3rd member, the 34th member, the 100th member, the 21st member, etc. So this is just a random list of 10 integers that were within this range. So that's kind of how that works. Okay. All right. Now let's look at this next method here. So when it's important for the sample to have members from each segment of the population, we use what's called a stratified sample. So when you think about the word strata, guys, I typically think of geology. You know, if you're traveling on a road that passes through a mountain or a hill and they actually had to clear part of that, you can look at the side of that hill. You can see strata. They're just individual layers that have been laid down through time. So much like that, strata within a population just are individual segments of the population, okay? And typically you use this stratified sampling whenever the population is given to being naturally divided into segments. And so there's some examples here. So examples such as age. So you might have one segment for 0 to 18, and then another segment for 19 to 35-year-olds, and then another segment for 36 to 50-year-olds or 49-year-olds, something like that. Also, gender, okay? You could segment a population by gender if that population that we're talking about consists of people, or it could consist of other animals. Ethnicity, political preference. This is a good example right here. So in high school, the population of students in high school is naturally segmented by class rank, right? You got your freshmen, your sophomore, your junior, your seniors. This also applies to college. Okay, so each of these classes is basically a stratum. And so typically what you would do is from each strata, you would select a random sample. Okay, so in this particular example here, if we've divided the population up into low-income earners, middle-income earners, and high-income earners, then from each of these strata, or from each of these segments here, you would randomly select a few. Okay, so you'd select a few low-income earners, a few middle-income earners, and a few high-income earners. And lots of times the size of each of these samples is equal. Okay, so that attempts to ensure that your sample is going to be as representative of the population as possible. Because we know not everybody's a low-income earner, right? Population, lots of populations, guys, are naturally segmented. So, all right, well, let's continue. Okay, so again, when the population falls into naturally occurring subgroups, each having similar characteristics, then we can take what's called a cluster sample. So to select a cluster sample, you're going to divide the population into groups called clusters. So this is similar to the stratified sampling, except the stratified sampling is pretty much already divided. It's just the nature of the population. But down here with the cluster sampling, you're actually dividing it yourself. And then you select all of the members of one or more, but not all of the clusters. Okay, so here's some examples. So areas in the U.S. are separated by zip codes. So if a researcher wants to survey a country without actually using a census, then they can use a cluster sample. So you could say that each zip code area is its own cluster. And so certain clusters or certain zip codes would be chosen, and then all the members in each of those clusters or zip codes are surveyed, okay, to obtain the data. So here's another example. You could also think about counties. And coincidentally, this looks a bit like northwestern Arkansas. Okay, this is just a random geographical area here. But you could break it up into counties or states even, right? Okay, so that's another example of cluster sampling. All right, and then we have systematic sampling. So systematic sampling, I think about products coming off of a conveyor belt or an assembly line. Okay, so if a manufacturer wants to determine the average lifespan, or life expectancy of a certain product, then they don't sample every single product that comes off the assembly line. That would be tremendously costly. Okay, so what they do is they pick maybe every 100th product that comes off the assembly line, or every 50th, or every whatever. So whenever you hear the word every, you're going to think about systematic sampling. Okay, so here's an example. An amusement park wants to gather some information about people visiting the park during the summer. So as people enter the park, you would select every 5th person and then survey them. Okay, the data is collected and analyzed to determine the demographics of the park goers. So here's a graphical example right here. So these are houses. So you could select, here it looks like every 100th household is being selected. Okay, so the first one is just a random choice, and then after that it's every 100th, 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 etc. All right, and then the last type, this is the one that you want to stay away from. But ironically, this is the one, at least in part, that you'll be using for your statistics project. Okay. So a convenient sample is just that, guys. It's a sample that's obtained out of convenience. So you don't go to any lengthy measures to try to obtain a sample that's representative of the population. So here's an example. A researcher wants to conduct a survey to determine which current best-selling books are the most popular with students at a certain college. So instead of using any of those other methods that we've talked about previously, the researcher just simply sits outside the library and asks students as they pass by. Okay, so it's the easiest, it's the sample that's the easiest to obtain. But it's also the type of sample that's not going to be very representative of the population almost all of the time, right? Because people that are coming out of the library are going to be markedly different or have certain characteristics or certain types of behavior that are markedly different from people that typically don't frequent the library. All right, so we've looked at these different sampling techniques. I think there's about 5 of them. So now we're going to look at some examples and try to figure out which of these techniques that we've just discussed is being illustrated or used in each of these examples. All right, so number 1. It says 35 sophomores, 24 juniors, and 25 seniors are randomly selected from 388 sophomores, 418 juniors, and 573 seniors at a certain high school. So each of these is a subset, and I would go with stratified sampling here. Okay. You could make an argument that this could be cluster sampling, but I'm going to go with stratified sampling because the population lends itself, the nature of the population is already segmented in a sense. Okay. So I think this is an example of stratified sampling. All right, number 2. And this is the key word right here, every fifth person boarding a plane is searched thoroughly. Well, because of the word every, we know this has got to be systematic. Okay. And of course, we know this is not actually how it's done. But, you know, if things like plane hijacking and different criminal acts on planes were not so prevalent, then what we actually try to do with security is we really try to take a census. Number 3, at a local community college, 5 statistics classes are randomly selected out of 20, and all of the students from each class are interviewed. This is the difference here, and I didn't think to mention this earlier. This number 1 cannot be cluster sampling because for that to have been the case, we would have had to have sampled every member from each of these clusters. And furthermore, guys, there's not very many clusters. There's only 3. So that's not going to be a good idea. Typically, you want to do cluster sampling when you can divide a population up into many clusters, right? Like all the zip codes in the U.S. or all of the counties in the state of California, right? Because there's quite a few of them. And here's another example of cluster sampling. So there's a total of 20 statistics classes, and 5 of those are chosen. So we're choosing 5 clusters out of 20, and of course all the students are interviewed or sampled. So this would be cluster sampling. Number 4, a researcher randomly selects and interviews 50 male and 50 female teachers. Okay, well the word right here, randomly, that basically gives it away. Okay, this is a random sample. I'm going to go with simple random sampling, okay? And then number 5, a researcher for an airline interviews all the passengers on 5 randomly selected flights. So again, this word right here, all. So the population is all of the flights, or all the people that are on these flights. But because we can break that population up into clusters, each cluster being a particular flight, and then we interview all the members on 5 of those flights, this is going to be cluster sampling. All right, number 6. A community college student interviews everyone in the statistics class to determine the percentage of students that own a car. This one I think is a bit tricky because it says everyone's, which means all of the students in that statistics class, but this is not cluster sampling. I think what's going on here, guys, is the population. The population here is all the students in the statistics class. So when you sample all of them, this is actually a census. Okay, that's pretty much all this one could be. And then number 7, oh, we got a couple more. Number 7, it says based on 11,000 responses from 48,000 questionnaires sent to its alumni, a major university estimated that the annual salary of its alumni was $118,000 per year. This one, I believe this one is convenient sampling, because the university didn't go to any great lengths. They just sent out 48,000 questionnaires and they got 11,000 responses, and they're going to use these 11,000 responses. Okay, so this is actually convenient sampling. Oops. Yeah. All right, number 8. A lobbyist for a major aerospace firm assigns a number to each legislator and then uses a computer to randomly generate 10 numbers. The lobbyist contacts the legislators corresponding to these numbers. This one, again, I think this one is random sampling. The distinction between these two is kind of subtle. Yeah, I'm going to go with random sample in this one because you're talking about selecting individual members, randomly selecting 10 individual members. Or well, although this could be simple random sampling as well. All right. The last thing we're going to talk about, guys, is bias. Okay, so we previously saw some examples of how bias can elicit certain types of responses from respondents. Just simply the way you word a question, because our words carry with them emotion. The things that we say, there's emotion attached to what and the way we say things or express ourselves. So let's look at this number 3. It says determine whether the survey question is biased. If the question is biased, suggest a better wording. So number 1, why does text messaging while driving increase the risk of a crash? I think that this is a biased question. The reason I think that is because you're implicit within this question is you are suggesting, before you've even sought out any responses, that text messaging already increases the risk of crash when driving. Okay. So I think number 1 is biased. Number 2 says, how often do you exercise per week? That one is not actually biased, guys. Now there are, you could say, well, it is biased in a sense because there's sort of an expectation that people should exercise because that's been what's pushed as being healthy and things of that nature. But this is just pretty much a point-blank question. How often do you exercise per week? And a valid response would be 0, meaning you don't exercise. Could be 10, could be 2, doesn't really matter. Okay? So I think that this is an unbiased question. Number 1, though, it says if it's biased, suggest a better wording. Let me think about this just for a second. All right, so for this one, there's not a whole lot I think we can do. I think it's this word right here. Why does text messaging while driving increase the risk? Using this word already implies that it does. So a better way might be to just simply say, does text messaging while driving increase the risk of a crash? Or I think you have to even be careful with how, because if you say, how does text messaging while driving, that also kind of suggests that it already does. So I think just the question, does text messaging while driving increase the risk of a crash, would be unbiased. And I'm not going to write out the whole sentence. But anyway. Okay. All right, so in this section we've looked at what an observational study is, an experiment, what goes into an experiment, what's necessary to make it a robust and replicable experiment. We looked at surveys and simulations, although to a lesser degree. We talked about bias, and then we've finished with talking about these different sampling techniques or methodologies. So guys, with that comes the conclusion of Chapter 1. So like I said, Chapter 1 wasn't really any math, it's just pretty much concepts, but these are very important concepts that you'll need to retain throughout the course. Okay. So anyway, I'll see you in Chapter 2.